Hello students, welcome back into the another session of CS07 data structure using programming in C. As all of you know that we are discussing about the unit number 2 called sorting and searching, and in this unit we have completed with various sorting techniques like bubble sort, insertion sort, quick sort, bucket sort, merge sort, selection sort. Now we are going to start with the last sorting technique, that is called as shell sort. So the theory of shell sort says that shell sort, also known as a shell sort or shells method, which is in a place comparison sort, that means shell sort is also called as comparison sort. It generalizes and exchanging sort such as insertion sort and the bubble sort by starting the comparison and exchanging of elements with the element that are far apart before finishing with the neighbor element. That means even this particular sorting technique sorts the number from smallest to highest, but this particular technique first compare the relevant element with its neighbor element. If it founds smaller than the neighbor element, then it first internally exchanges the value, and then by comparing and exchanging the value with each other, lastly it will give you the sorted data. So the same thing is written over here. Starting with far apart element can move some out of the place element in a position faster than the simplest near neighbor exchange. The founder of shellsort is Donald Shell, published the first version of shellsort in 1959, and then by various improvement into the shellsort technique, he has released the final version of shellsort program. So as far as the university examination is concerned, this shellsort is not that much important, but still we have to keep in our mind the theory of the shellsort. The shellsort itself works on one mathematical model which is called as d is equals to n plus 1 divided by 2. Algorithm of shellsort is very simple, which we can demonstrate over here. Algorithm of shellsort is like this, where it consists of total 8 steps. Step number 1 is an initialization of two variables, where the variable number 1 is array and variable number 2 is a total number of element called n natural number. Then step number 2 is the initialization of a gap by giving the equation called n divided by 2. Step number 3 is it will check the gap and one for loop which initializes the variable I is equals to the value of gap, and it repeats less than n, and every time it increases the value of I by 1. Obviously we will get confused with the word called gap. Gap means what? Gap means the difference between the smallest value and the highest value, that is called as gap over here. Step number 4 is an initialization of third variable called x for every item of the array element which we have declared. Then step number 5 is finding the proper position of target element. That means we have to rearrange all the numbers from smallest to highest, so for that every small number should be placed on a specific position. So to setting up every element on a specific position, this particular two logical statement will work. That is, for j is equals to I minus gap, j greater than 0, greater than equals to 0, and item of j is greater than x, and j is equals to gap minus j. On every repetition of this looping control structure called for, it updates the position of element which necessary suits for every element and set every element on a proper place. Step number 6 will insert. There is a difference between step number 5 and step number 6. Step number 5 find out the place, and step number 6 will insert that particular element on the place which has been founded by step number 5. So only this update logical line is written over the step number 6. Once every steps is repeated, we will find that the shell program is completed and it stop executing the entire code. This algorithm is little bit difficult to understand, but don't worry, in exam it might not be asked. We will see the program of the same. Let's first compile the program and then we will see it over the notepad. So this is the program. This program will demonstrate the shell shot. Let's execute it. As you can see that there are no syntactical errors are there, even there are no warnings. Let's execute it. Give the size of array, suppose I am giving 5. Then I am inserting any 5 unshorted number like 2, 0, 1, 6 and 3. So the output is 0 is the smallest element from the entire unshorted list. Then the second highest is 1, third highest is 2, fourth highest is 3, and the highest element of this entire unshorted value is 6. So the numbers get shorted using this particular technique called shell sort. So now let's see how this particular program works. So it's better to visit this program over the notepad instead of Turbo C editor. So I'm opening it on the notepad. So this was the code. First write down the definition, write a program to perform shell shot. Write a program to perform shell sort. This is the definition. Fine. Now after the necessary library functions like hash include stdio.h and console input output.h, there is a function prototype where the name of my UDF is shell shot. It contains the two parametric values. One is the array and second is the n natural number. Function prototype of this line is function with argument without return value. So void is written over here as it is a without return value. Then into the void main statement and its opening and closing bracket, I have initialized 3 variables, that is I, n and a of 10. That means this particular program can sort maximum 10 numbers. Then there is a CLR SCR word. and one message for the user that enter the array size. Whatever the size entered by the user is going to be stored inside the variable called n. Say for example, suppose I have entered size called 5. So this 5 is going to be stored in this n. Then for n times, different element is going to be accepted by the program by giving the intimation message that enter the elements of array. For I is equals to 0, I less than n, I plus plus, into the bracket scanf %d n% a of I. That means this line of code will accept any 5 unsorted number from the user. Say for example, I am giving 601, 4 and 3. So these are the unsorted 5 numbers. All that unsorted 5 numbers are stored in this one dimensional array. Then after there is a function called, this particular line will call the function called shell sort, where it pass all these unsorted number and the total element of the array, that is called as 5. So from over here, program goes into the function initialization stage. So let's scroll down the program. In function initialization, first of all these unsorted number stores in this one dimensional array, and this 5 is stored inside the variable called n. Once this process is completed, this bracket where initialize 3 more variables, that is d, I and temp. And the next line of code find out the exact gap. In our algorithm, we have taken one terminology which is called as gap, where the equation of finding out the gap is n divided by 2. So the same thing is done over here. So this d, instead of word called gap, we can take any word. So I have taken the word called d. So just consider d is equals to gap. If gap is greater than or equals to 1, that means if the value found positive into the gap, one loop initialize over here which starts from the 0th position and it repeats up to the one previous position of the total number of elements. That means these are the total number of elements. Say for example, this is the first element and this one is the last element. Then for all these remaining element, deduct first and last. For all other element, this particular for loop will work. During this repetition, it compare every element with the previous with the next element, and if it founds less than the previous element, then it will exchange with the previous value. That means 6 is compared with 0, and if 0 is founded smaller than this 6, then it get exchanged like this. That is 0 is replaced 6 is replaced with 0 and 0 is replaced with 6. Then 6 is compared with 1. If 1 is found less, then 6 is replaced with 1 and 1 is replaced with 6. Again 6 is replaced with 4. So 6 is replaced by 4 and this 4 is replaced by 6. Again the comparison of 6 is done with 3. So instead of 6 there is 3 and instead of this 3 there is a 6. Now the final position is fixed, that 0 is the last and 6 is the highest value. Then again 1 in 4 is compared, but in this comparison this is false as 1 is smaller. Then 4 and 3 is compared. In this comparison 4 is replaced by 3 and 3 is replaced by 4. Ultimately you can see that the entire list is get sorted. So that thing is done by this particular loop, and it stop all this comparison when the gap is founded to be is equals to 1. That means if there is no gap in between the small and the largest value, automatically it returns from function initialization to the function call, and this this function called prints all the sorted elements by executing the for loop called for I is equals to 0, I less than n, I plus plus, printf percentage d a of I, which ultimately prints all the sorted elements. One more thing over here we have not discussed. This is d is equals to d divided by 2 0.0 plus 0.5, which is actually used to set the gap from negative to positive. So this was all about the shell sort, that how it sorts the number. I request all the students just write down the program by pausing the video. Just write down the program by pausing the video. First write down this selected line of code. That means just pause the video and write down this selected line of code. Then again pause the video and write down the remaining line of code. I hope all the students have successfully written this code for shell sort. So as per the prescribed syllabus of Saurashtra University, all the sorting techniques gets over here. Now from the list of all sorting techniques like bubble sort, insertion sort, quick sort, bucket sort, merge sort, selection sort, and the last one is called as shell sort. The most important sorting techniques are: number 1, bubble sort; number 2, quick sort; number 3, selection sort; number 4, merge sort; number 5, insertion sort; and number 6 is shell sort. So as per this, kindly prepare yourself for the various sorting techniques. That means bubble sort is very important. Then next one is quick sort, which is again very important. Third one is selection sort, which is again very important. Then bucket sort, even it is very important. Very rarely they can ask about merge sort and shell sort. So just keep this thing in your mind, and as per this, prepare the sorting technique. Question may be asked like this. I am just giving you the idea of bubble sort. Write a short note on bubble sort. So what we have to do for this particular question? First, write down the theory of bubble sort. Then write down the algorithm of bubble sort. Then write down the program of bubble sort. And then by giving a one sample value, give the sorted data. This question might be asked for the maximum number of marks. So if very less number of mark is there, even they can ask only the algorithm, only the program and only the theory. But we have to prepare every topic in such a way that every sequence should be maintained. So just maintain the theory, then the algorithm, then the program and then the relevant output. So now without wasting more time, let's go ahead. All this was all about the various sorting technique, but this particular chapter is made up of two components. One is sorting, which we have completed. Another is searching. So in data structure, there are two types of searching techniques are there. One is linear search and another is binary search. Before going in detail about these two searching techniques, it should be clear that what is the meaning of searching itself. Sorry, there are three searching techniques are there. One is index, second one is sequential, and third one is binary. These two are very important, but first we will discuss about what is the meaning of search. Search means this is the technique which find out, this is the technique which find out specific element from the list of elements. That means suppose we have sorted or unsorted list of element. First I will demonstrate with unsorted list. Say for example, this is the unsorted list. This is the unsorted list and I am giving 0 as a search value. So what it does, this 0 is going to be compared with 5. Condition becomes false. Then 0 is going to be compared with 2. Condition becomes false. 0 is compared with this 0. Condition becomes true. That means search is successful. Still remaining two elements are there. So again 0 is compared with 1. Condition becomes false. 0 compares with the last element, condition becomes false. So search becomes true over the position called 2. All these elements are set on a one-dimensional array on various position, like 5 is on position number 0, this 2 is on position number 1, 0 itself on position number 2, 1 is on position number 3 and 3 is on position number 4. So this key element, the data which we want to search is called as key element, found true on a position called 2. So whenever we are searching key elements, based on location. Again I am repeating my words. Whenever we are searching the elements based on location, that searching is called as index search. Spelling of search, SEARCH, right, index search. That means if 0 is founded on location number 2 and we are displaying that location, then this searching is called as index search. Sequential search means instead of printing the location ID of the search element, we are itself displaying some successful message that search is successful. Then that is called as sequential search. In sequential search, the element which we want to search is going to be compared with all the previous and pre and post element of the search element, that is called as sequential search. And binary search means before the searching appears, we need to sort the data. That means this unsorted data is first converted into the sorted data and then the searching get executed. Suppose once the data is get sorted and we are searching 0, ultimately it get found on the first location. No need to go for searching and comparison, searching the values on various other locations. So binary search is more faster searching technique than the other techniques that we have discussed, like index and sequential search. But still, we will discuss all these things programmatically. Even we will discuss an algorithm of all this searching technique, and even we will discuss theory in detail about all these searching techniques. So in my next lecture, we will have a look about various searching techniques like index search, sequential search and binary search, which ultimately completes the first section of unit number 2, that is called as sorting and searching. Quickly, we will complete these searching techniques. As far as the examination point of view is concerned, from these 3 searching techniques, binary search is very important. So thank you very much students for listening me, and have a nice day.